Okay, let's look at number 2 and 14.3. And in number 2, we have r of t is t squared sine t minus t cosine t, and cosine t plus t sine t, and t is between 0 and pi. And we want to find the length. So the length is the integral of 0 to pi, square root of, take each of the derivatives. So the derivative of f is 2t squared. The derivative of g is cosine t minus, here we have to use the product rule. I'm taking the derivative of each one. Okay, then that's going to be the integral of 0 to pi square root of 4t squared that's going to cancel. So I have plus t squared sine squared t. These cancel. Plus t squared cosine squared t. So that works out nice. The sine squared plus cosine squared is 1, so that's just t squared. So I'm integrating 5t squared, so I'm integrating 5t. I don't need the absolute value there on the t because I'm integrating 0 to pi, and that's positive. So this is going to be square root of 5t squared over 2 from 0 to pi. It's the square root of 5 over 2 pi squared. And number 10, they're asking us to reparameterize the curve with respect to arc length, where t equals 0, and I have r of t equal e to the 2t cosine 2t plus 2j plus e to the 2t sine 2tk. So I'm going to find r prime first, and that's going to be e. Again, I have to use the product rule. I'm just going to line them up here, 0j, and then k is and find the magnitude. See, so it's going to be that squared I don't need that. I'm not integrating. Okay. All right. Now, I multiply all this out. Those are going to drop out. Here I have 8 sine squared e to the 4t plus 8 cosine squared, so the 8 and the e to the 4t can get factored out. Cosine squared plus sine squared is 1. So that's going to be 2 square root of 2 e to the 2t. And that's what ds dt is. So then I integrate that. And the integral of that is 2. Well, I'll just write it all out. Okay, divided by 2, so it's going to be square root of e to the 2t minus, and plug in a 0. Well, I'll do all my work. I'm going to plug in 0. That's just going to go to 1. Alright, so I have s is equal to square root of 2 e to the 2t minus square root of 2. I solved this for t, so I'm going to have s well, let's factor out. So it's s divided by square root of 2 is e to the 2t minus 1. S over square root of 2 plus 1 is e to the 2t. Then take the ln of both sides. And then divided by 2. So that's what t is equal to. And then all I have to do is go back and plug it in for r. Remember, r of t was e to the 2t. So e to the 1/2 ln s square root of 2 plus 1 cosine 2 of all that. Two, and then the k part was e to the 2 and simplify that. E and ln drop out, so it's just s square root of 2 plus 1 times cosine ln s over square root of 2 plus 1. 2, that drops out. E and ln drop out. And then that's the, I re-parameterize this, and so now this is a function of s. And it depends on the arc length and not the, not t. Okay, let's look at excuse me, 16. Okay, 16. I want to find unit tangent and unit normal vectors. So r prime is 2t, 2, and 1 over t. Notice here that t has to be greater than 0 in order to take the natural log. So the magnitude is each one of those squared added together. That simplifies. And since t is greater than 0, that's just 2t plus 1 over t. So the unit tangent vector is just r prime of t over the magnitude of r prime of t, which is 2t to 1 over t, divided by this, but that's the same as times, so that's equal to 2t squared 1 over 2t plus 1 times 2t squared 2t and 1. That's a squared. All right. Now, to find t prime, okay, so that's the unit tangent vector right here. To find the unit normal vector, we got to find t prime, and that is the product rule. So it's 1 over 2t squared plus 1 times derivative of this plus the derivative of that okay, you have to use a chain rule there, so that's here 4t. Okay, factor out 1 over 2t squared plus 1 squared, and that's going to be 4 2t squared plus 1 minus 8t cubed, 2 times 2t squared plus 1 minus 8t squared, and 0 minus 4t. That's 1 over 2t squared plus 1 squared. That's that's 4t. So that's 8t cubed. That's going to cancel with that. Plus that's going to be 4t. This is going to be 4t squared. That's going to be minus 4t squared plus 2. And that's minus 4t. Okay. Now we got to find the magnitude of that. And there really isn't any easier way to do this. It's the square root of the derivatives of, these are the derivatives, so each one of those squared. So it's going to be over t squared plus 1 to the 4th, 16t squared plus, okay, that's going to be 16t to the 4th. I'm going to FOIL this out. So these are going to cancel. That's going to be, let's take out a 4. So it's going to be 2 square root of 4t to the 4th plus 4t squared plus 1 all over t squared plus 1 squared. That's going to be 2. Inside here is 2t squared plus 1 squared. When you take the square root, you get 1. So that's going to cancel with one of those. All the top is, so that's just going to be 2 over 2t squared plus 1. So t prime over the magnitude of t prime is going to be 4t, 2 minus 4t squared, negative 4t, all over 2t squared plus 1 squared, times the reciprocal of that, And we'll take out a 2, so that 2 is going to cancel with a 2 in each of that, so that's going to be 2t, 1 minus 2t squared minus 2t times 1 over 2t squared plus 1. And this right here is the normal unit vector, t prime, or the magnitude of t prime. Now the curvature is t prime over r prime, so that's going to be 2 over 2t squared plus 1 over 2t plus 1 over t, and that's going to be 2t times 2t squared plus 1 squared. Okay, so basically it's just a lot of algebra. 18, I want to use theorem 10. It says, so r is t 1 plus t squared. That's r of t. So r prime is 1, 1, 2t, and r double prime is 0, 0, 2, and the magnitude of r prime is the square root of 1 plus 4t squared, which is the square root of 2 plus 4t squared. So r prime cross r double prime isn't going to be too hard to find because there's a lot of zeros. So this is going to be 2i minus 2j plus 0k. So the magnitude of that is square root of 4 plus 4, which is the square root of 8, or 2 square root of 2. So curvature, again, is r prime cross r double prime over r prime cubed. So that's going to be 2 square root of 2 over the square root of 2 plus 4t squared cubed. Okay, we can simplify that. We can take out a 2 and 2 square root of 2 cubed is exactly what that is. So this is our final answer. That's the curvature using that different formula. Okay, 24. If y equals cosine x, now we have a function in terms of x. We're going to use that other formula. So the formula is f prime over square root of 1 plus f prime squared cubed. And f double prime, the absolute value is cosine x over square root of 1 plus sine squared x cubed. That's it. So we've used each one of the formulas for curvature. In number 40, we have r equaling that at the point 1, 0, 1, so that's when t is equal to 0, and r prime is e to the t, e to the t cosine t, plus e to the t sine t. I'm using the product rule. factor out of e to the t. Okay, to take the magnitude of that, that's going to be the square root of e to the t squared. So e to the t is going to come out because it's positive. And when we square that, we're going to get 1 plus cosine squared plus sine squared plus 2 cosine t sine t. And the next one we're going to get sine squared plus cosine squared minus 2 sine t cosine t. When I square the components, that's 1 and that's 1. So that's just square root of 3 e to the t. So t, the unit tangent vector, is 1 over the square root of 3. The e to the t's are going to cancel. And I have that. So that's the unit tangent vector. And t of 0 is going to be 1 over the square root of 3, 1, 1, 1. T prime is going to be 1 over the square root of 3, 0, minus sine t plus cosine t, minus sine t minus cosine t. So the magnitude of that is square root. Again, I bring that out because I'll square it and then take the square root of 0 squared plus square this. I get sine square t plus cosine square t minus 2 sine t cosine t. Square the next one. Cancel, cancel. Now I just have 1 and 1 is 2. So that's going to be square root of 2 square root of 3. Okay, so t prime over magnitude t prime is 1 over the square root of 2, 0, cosine t minus sine t, minus sine t minus cosine t. That's n. So n of 0 is going to be 1 over the square root of 2, 0, 1, negative 1. So that's going to be the normal unit vector. And then to finish it up, we're going to find the binormal vector at 0, which will be t cross n at 0, which is I, j, k, 1 over square root of 3, 1 over square root of 3, 1 over square root of 3, 0, 1 over square root of 2, minus 1 over square root of 2. That's I. So that's your binomial vector at 0. That's b of 0. Okay, so I hope this helps when it comes